geometry students. All right, last night's homework was all about angles that were at the center of a circle, which is what I've drawn here. That point is in the center of the circle. And instead of giving you a bunch of letters, I just called the angles 1, 2, 3, and 4. It's a little easier that way. All right. I'm going to try and explain this in a little more detail than what I did yesterday and just focus on the ones that are at the center of the circle. So everybody knows there's 360 degrees in a circle, and everybody should know that angles 1 plus 2 plus 3 plus 4 also add up to 360 degrees because both those lines are diameters. So like angle 1 and angle 2, that's a linear pair. They make up 180 degrees. Same with angles 3 and 4. Those are a linear pair. They make up 180 degrees. And if you put all four of them together, they add up to 360. Well, the outside, the circumference of the circle, that's also 360 degrees. So angle 1 is going to have the same amount of degrees as that arc right there. Angle 4 is going to have the same amount of degrees as this arc right here. Same with 3 there and 2 over here. So basically those two diameters split the circle into 4 sections. Each one of the sections has an angle and it has an arc, and those amounts are the same. All right, if you can imagine shifting this vertex, say, down, then it would look more like this. 1, 2, 3, 4. So that point now is no longer in the center. And when I shifted it down, angle 1 didn't change its size, but now it's cutting off more of the circumference. Its arc got bigger, whereas the opposite, angle 3, it's getting the center, the vertex is getting closer to the bottom. Angle 3 is cutting off less of the circumference. So maybe that'll help you visualize why the formula for if the vertex is in the circle, that you have to add these two arcs together and take the average to find one of those. All right, I'm jumping ahead a little bit. This is, I think, Wednesday's homework. As far as the homework for tonight, it's on the circle. So I have a slate made up for that. So if you're on the circle, I'm going to walk through 4 examples with you, and then we'll be done for the day on this video. This first example is not finished. This is the one I'm going to use to explain to you why, if a vertex is on the circle, its arc is twice as big as the measure of the angle. So here's my explanation. Imagine that diameter intersecting the tangent of the circle. So I just drew in the tangent. Now a tangent only intersects the circle at one point, and it's always perpendicular to the radius that intersects at the same point. So that's a 90-degree angle. Well, that 90-degree angle, basically its arc that it's intercepting is the whole half of this circle. And if there's 360 degrees in a circle, that means this arc from here all the way up to there is 180 degrees, but yet this angle we can see is only a 90-degree angle. So that's a good example to think back to if you forget how to do an on problem. You could think of this example and say, oh, that's right, a tangent, that's 90 degrees, and it's cutting off half the circle, which is 180 degrees, so the arc must be twice as big as the angle. So that's a good example to remember the rule by. All right, and now these are just using the rule. If angle 1 is 40 degrees, what is the measure of arc AB? Well, it's going to be twice as much as the angle, so that would be 80 degrees. All right, the on ones are fairly simple. The arc is twice as big as the angle. Now you could also work backwards. Instead of given the angle and trying to find the arc, you can be given the arc and you have to try and find the angle. So if you're given the arc here, this arc would be 100 degrees. That means the angle is 50 degrees. Now this is where it starts to get a little bit more complicated. A problem like here is where you have more than one angle that's on the circle. So you have angle 1 right here that's on the circle, and you have angle 2 down here that's also on the circle. Well, they both happen to go to the same points. Angle 2, the end point goes to A of the one ray, and the other ray goes to B. Same with angle 1. Angle 1 is going to A, and it's also going to B. So they're both intercepting the same exact arc. that means those two angles are going to be the same exact size because they're both going to be exactly half of this arc, just like this example here. The arc was 100 degrees, half of that was 50, so angle 1 was 50. If I were to draw another angle on this example, anywhere on this circle, as long as I draw it so that they both go to AB, like say here, boom, and right there, call that angle 2, then that angle 2 is also 50 degrees because it's intercepting the same 100-degree arc, and that's what we have here. Both angle 1 and angle 2 are intercepting the same 120-degree arc, so they're both half that size. They're both 60 degrees. All right, so yesterday I just kind of explained to you what the formulas were. I didn't give you really any examples. So today you've got your examples. The homework for Tuesday is all about on. Hopefully this is enough that you'll be able to successfully solve the problems. If not, feel free to email me and I'll try and give you a little bit more help. All right, end of video is now.